13, 14, and 15, we are solving a radical equation. Going to have square roots in these ones. If I have a square root in the problem, I want the square root term to be by itself. It is on this problem. And to get rid of the square root, I do the opposite, which is squaring. So I'm going to square both sides of my equation. Now if I think about this with a number, if I have the square root of 3 squared, that means I have the square root of 3 times the second square root of 3. Square root of 3 times the square root of 3 is 9. Well, 9 is a perfect square. I can do the square root of 9. I just get the plain whole number 3. So, squaring undoes a square root symbol and you get whatever's underneath. So, squaring the square root of w minus 11 would just give me w minus 11 and it gets rid of the square root symbol. The other side didn't have a square root symbol. 5 squared, 25. I then solve this like I solve everything else, so I'm going to add my 11, move it to the other side. W is going to equal 36. Now when you're working with square roots, sometimes you get what's called extraneous solutions. Although you did all the work correctly, the answer doesn't check. So you always want to go back and check your answer. Is the square root of 36 minus 11 equal to 5, right? I put the 36 in for the W to check it out. Well, 36 minus 11 is 25, and sure enough, the square root of 25 is 5. My answer does check, so that's a good solution. Number 14, I'm solving for u. Again, this one has a radical symbol in it. It has a square root, but it's not by itself. So before you can square both sides, you have to move the number to the other side and get the radical by itself. So in this case, I'm going to go ahead and add my 2 and say the square root of u minus 6 is equal to 5 plus 2, which is 7. Now that I have my radical by itself, now I can go ahead and square both sides and use my rule. If I square my square root, I just get the u minus 6. 7 squared is 49. I want to go ahead and solve that, so I'm going to just go ahead and add my 6, and u is going to equal 55. Again, I want to check my answer. 55 minus 6, square root of 55 minus 6, minus 2, does that equal 5? Well, 55 minus 6 gives me the square root of 49. The square root of 49 is 7. 7 minus 2 is 5. Yep, that checks out, so that is a good answer. Number 15. I want to solve this for u. Again, the square root is not by itself. I need to move the 14 to the other side. So I'm going to minus my 14 and say the square root of u plus 20 equals negative 13. Some of you might think there's a problem to begin with right here. Some of you might not recognize the problem. So we're just going to go ahead and solve it. To get rid of my square root, I square both sides. Squaring my square root would give me u plus 20. Negative 13 squared. Make sure you use the parentheses. I have to remind you of that all the time. Negative 13 times negative 13 is a positive 169. Solving that, I would minus my 20, and I would get u equals 149. I'm going to go ahead and check that. 14 plus the square root of 149 plus 20, does that equal 1? That was my original problem. 14 plus the square root of 149 plus 20 is 169. The square root of 169 is 13. Well, 14 plus 13 is 27. Wait a minute. 27 doesn't equal 1. Even though I solved that correctly, that answer is not going to work out because when I squared this negative, became a positive, and I got one of those extraneous solutions. Square roots are never going to equal negative numbers over here. That's why I said some of you might have recognized right away that, oh, I can't do that. But had I finished the problem and went back and checked it, I'd for sure find out, nope, I can't do that. Square roots can't equal negatives. And so in this case, my answer, no solution. And you will have some that come up to no solution. So make sure you check your answers when you're done to make sure they come up correctly.